So today's lesson is looking at calculating probabilities of z-scores on the left. So in previous lessons what we've been doing is that we know the mean is in the middle, we've got a standard deviation, and we have been working out the area to the right. Starting with this lesson, we are going to start looking at z values that are negative. So in other words, to the left, over here. So a lot of this is going to use the same skills that we've got already. We're just using them in a slightly different way with slightly different language. So let's take a look at the problem. So sheep weights are normally distributed with a mean weight of 84.1 kilos and a standard deviation of 4.6. So no difference there. That's what we're normally dealing with. So that's fine. What is the probability that a randomly chosen sheep has a weight between 81.018 kilos and 84.1 kilos? So this should be automatic now. We should be able to go straight through and think, right, what are my steps? First thing, draw a picture. So I've got my bell curve again. I'm going to put my standard deviation, which our mean, which is 84.1 kilos, our standard deviation, which is 4.6. And then I'm going to put some numbers. Well, that's the mean, so that's going to be the first part of my area. And the other one that I'm dealing with is here is 81.018. Well, that's normally we've been dealing with numbers on this side, on the right hand side, being bigger than 84.1. But 81.018 is less than that. So what we have to do is trying to work out what the size of this area is. So now that we've drawn our picture, what we can do is start to look at calculating the z-score. And the good news is the formula is exactly the same, so we can put that into our calculation. So the z-score for this one is going to be 81.018. Take away 84.1 divided by 4.6, the standard deviation. Now I put that into my calculator, which gives us an answer of minus 0.67. So we haven't had a minus before, and the reason why we haven't had a minus before is we've been dealing with things on the right hand side. So remember, in z values, the mean is 0, so anything less than that is going to be a minus. So 0.67, having a minus isn't too much of a surprise. Now, that brings us on to the next part, which is looking up in the z table. Now, what we've been dealing with previously is we've been dealing with positive numbers. So you'll notice that the table doesn't have any negative values. There's no negative z's on down this column, and even you'll notice at the top of the sheet of paper, the chart, it will have our graph. It will only have the right hand side shaded to whatever the z value is. But the thing is, you've got to use the features of a normal distribution, which is that it's symmetrical. So it doesn't matter if I'm trying to find positive 0.67, that's going to be the same either side because of that mirror line either side of the mean. So there is no negative table that you have to use. There's only the positive one. It's just you use it. You use the same values, and whether it's a positive or a negative. So what that means is that we have to find 0.67 So if we take a look here, so we've got 0.6, 0.7, which takes us across to this value here, which means that this area, so the chart says this area is equal to 0.2486. So it means that this area, if it's symmetrical, is 0.2486. Which moves us on to the last step of answering our question. Which is write the probability in context. So the probability that a sheep's weight is between 81.018 kilos and 84.1 kilos is 0.2486. That's it. So it's pretty much the exact same question that we started with looking at values on the right. It's just that we've got this extra element that we've got a negative that we have to deal with. So the next question, the density of a pounamu is normally distributed with a mean of 3.3 kilos, 3.3 grams per cubic centimetre and a standard deviation of 0.011 gram per cubic centimetre. What is the probability that a randomly selected piece of pounamu pounamu's density is more than 3.29505 grams per cubic centimetre and less than 3.3. First thing we should notice is that's the mean and that's the mean. So it's similar to the question we just looked at. What I want you to do is have a go from start to finish. Try and get me an answer. So pause the video and then have a go at it. Okay, hopefully you had a good go at that. So first thing, draw the picture. Okay, hopefully that's what you got drawn. So the next thing, calculate a score. That's going to be Z is equal to 3.29505, take away 3.3, divided by 0.011, and we chuck that into the calculator, which gives us minus 0.45. So back to our chart, we've got 4 and 5, so that means we end up with 0.1736. So now that we've got the probability, we can move on to the next part, which is to answer our question in context. The probability of the density of a piece of pounamu being between 3.29505 and 3.3 is 0.1736. So the final steps, draw a picture. In this case, we are going through this part where we have the mean and the Z value. Calculate the Z score using the formula. Look up the probability from the table. And lastly is write your answer in context. The probability of X being between and is... Okay, so that's the end of this part. There's a worksheet to follow this and also a bit in the book to complete. You can do that now.